Good morning.
Good morning.
Good morning.
So, how is everyone?
Superb.
Oh, that's a great answer. I love to hear that. So, let's see. Holbrook, you guys have a half day, right? But your schedule's all messed up because of me, right? Well, actually, it's not my fault, but anyway. Now, do you guys have a half day in Winslow today?
No,
Tomorrow? No?
No.
All right. And then let's see. Joseph City, do you guys have you don't have parent teacher conferences today. That's after spring break?
Yeah.
Yeah, because I know that's why Holbrook has the half days because of parent teacher conferences. So anyway, all right, well let's see who's here today. Okay, so Rex.
Here.
Okay, so Rex, what was the name you put in your email yesterday?
So my first name is Rex, but I go by Toby. So I usually always put Toby for everything. So I apologize for putting
No,
that.
it's okay. I just hear it's all March, and I've never called you by the name you go by. So
Yeah, I always forget to put Rex when I'm doing like college stuff. So I apologize.
No, you're good. You're good. Do you want me to change your name on the Wheel of Fortune?
You can if you want to. It doesn't really matter though.
Okay. All right.
Mr. Strong, I
Anyway,
have a question really quick.
Yeah, sure.
So we're gonna finish 8.3 today. Are we gonna go on to 8.4? Or are we just
Yes.
okay?
So what we're gonna do? We are gonna go to 8.4, and then after spring break, the 2 days that you'll have with the sub, you'll be continuing on with new material. However, those days we will. I'm going to mention to the sub to answer questions that anything that you have. Even today, if you have a question that about the midterm or something like that, I would be happy to do that too. So. Because our main thing is to help you for the midterm, but then after that we need to keep going. So yeah, we are going to go on to 8.4 today. All right. Anything else? All right. So if you've got a question, be getting that out while I continue with the roll. Alana.
Here.
Diana.
Here.
Taylor.
Not here.
Auburn? No Auburn today? All right. Cameron?
Here.
Andrew?
Here.
Chandon?
Here.
Junior?
Here.
Hayden?
Here.
Jordan?
Here.
Ellie?
Here.
Dominic?
Here.
Brooke?
Not here.
All right. So no Brooke, Auburn, or Taylor. Okay. So so just to kind of remind you of the schedule. Oh, let me share that. Hold up. Okay. So next week's spring break. I know you all know about that. And then Monday and Tuesday, you'll have a substitute. It's going to be Mr. Fritz. So he'll know what's going on. So you can ask him questions, but he's going to go on to 8.5, maybe 8.6, depending on the speed or whatever. And then the thing is, though, is that I know he's going to teach it differently than how I do it, but any questions, anything thing, we'll clean it all up when we get back. Okay, so I'm not worried that if he teaches something a little different than me, that's fine. That might help you understand something better. And then I do want you to feel comfortable asking him questions about the final. The midterm, sorry. And midterm will be on Wednesday and Thursday. Open book, open note. There will be a time limit, just very similar to kind of how we did it last semester. All right. All right. Any other questions about that? I will be around. I'm not again that week. I'm working on university business with that hiring committee. So I will. It's not like I won't be able to access my email and so on. So you can still reach me. It's just not. I'll be in meetings all day, and then then I'll kind of deal with whatever. So okay. All right. Well, the first, actually, as we were finishing yesterday, we're like, I don't know, 5 minutes from finishing 8-3. But there's I didn't want to blow through this one thing because I think this is kind of neat. If you want to grab your calculators and get those out, and what I want to do is we were talking about parametric mode. So if you would go into parametric mode, and then type in x equals cosine t and y equals sine t. All right, and then if you press graph, then it should be a circle. Now you might need to zoom in. Here I'm showing my window. If you want to, I went from 0 to 2 pi on the t's. So if it doesn't look circular and it looks more like jagged sides or whatever, you might need to change that. And so, does anybody know what this is? What's so special about this? Well, this is the unit circle. So it's a way to get the unit circle on your calculator. So if you press trace and then type in an angle, then it'll tell you the sine and cosine of that angle. So if you do radians, if you're in radian mode, and you do trace and then like pi thirds or something like that, then it'll say x equals, and so x is the cosine of the angle, and then y is the sine of the angle. And so you can find, the sine and cosine of any angle, and it'll show you where it is on the unit circle. So I think that's pretty cool. All right, any questions on that? You don't have to know how to do that. I just thought they're parametric equations. It relates with what we're doing, and it's kind of cool to be able to, put the unit circle in the calculator. So anyway. Okay, so the last thing as far as graphing goes was to construct parametric equations from one equation. So like if I had y equals x squared plus 3, the way to break it down, you can let x be, the easiest way is to let x be t. But you can let x be 5t, x could be 3t, x could be anything. But the easiest way to do it And so that's the way I do it typically, is just to let x be t, and then just substitute in t for x. And so then y equals t squared plus 3. So this is your rectangular equation, and this is these are your parametric equations. All right? So see if you can do that last practice problem. Okay, so you let x be t, and then to get the y equals, you substitute x for t. All right, so in this practice problem, so if x is equal to t, then what would y be? Anybody?
4t minus 3.
4t minus 3. Okay? And so that's your parametric equations. That's it. Okay? All right. So any other questions on 8.3?
Oh, and Mr. Strong, when we looked
Yeah.
for 8.2 to take the quiz, we couldn't find it. So
Okay. All right. I was sure I posted that, but I'll take a look at that, make sure it gets on there. Okay? Thank you. All right, anything else? All right, well, let's go on to 8.4. So, 8.4, then this material and the new stuff that you do Monday and Tuesday after spring break will not be on the midterm. So this is on the final, but not on the midterm, okay? So 8.4, this is called the trigonometric form of complex numbers. Now, this, I have to be completely honest with you, this used to be extremely important, an extremely important section. But with the advancements in calculators and computers, this is really not near as important as it used to be. But this would be like one of the most, you know, if you were a student, as you were taking advanced math, this would be one of the sections that would really save you loads of time, hours and hours of time. And now, not so much. I mean, it's kind of cool, but it really isn't nearly as important as it used to be. But we still need to know how to do the trig form. It's just the shortcuts aren't quite as amazing as they used to be. Okay? So, we're going to talk about, kind of review complex numbers a little bit. And I know we did complex numbers last semester, but now we're going to relate them to trigonometry. And see, we haven't done that before. And then we'll talk about putting complex numbers in trig form. And then what that does is it allows us to multiply, divide, and raise them to powers and roots while they're in trig form. And it's so much easier than in complex form. And so the trigonometry really helps us. Okay?
Mr. Strong,
Oh, yeah, go ahead.
just to let you know, we don't have notes here in Joe City because Miss Buckley isn't here.
All right. We got to talk to Miss Buckley about getting to work. showing up. No, I don't know. I'm just kidding her. She's a good friend of mine, so I can tease her. But all right. Well, thanks for that. So when just kind of write down the blanks. Don't write down the whole thing because I know you'll get them. And is she coming back later, or would you suggest I just put them on the? You want me to? Do you want me to put them on the Moodle, or just wait and just when she gets there she'll print them out, or how do you want to handle it?
Probably just put them on the Moodle.
Okay. All right. I'll look for that one to do that when I make double check on those quizzes as well.
Okay. Thank you.
You bet. Yeah, I actually just finished them about 15 minutes before class. So anyway. Okay. Well, let's kind of review complex numbers here. So complex numbers when we have like a plus bi, like 2 plus 3i or whatever. And then when we graph complex numbers, we have a real axis and the imaginary axis. So if you were going to graph, let's say 3 plus I, you would go over 3 on the real axis and then up 1 on the imaginary axis. Okay? So this would be like -2 minus I. You'd go -2 along the real axis and then down 1 on the imaginary axis. Okay? So that's how you graph. Now, you might remember in real numbers along the number line, we refer to the absolute value of a number as being its distance from 0. Well, for a complex number, its absolute value is like it's like the same thing. It's the distance that complex number is from 0, from the origin. But it's like we're using a triangle here, or the distance formula. And so one of the big ideas in this is trying to find this distance, the absolute value, or sometimes we call it the magnitude. And so the absolute value of like 3 plus I, you say, well, it's kind of like finding the hypotenuse of this right triangle, 3 plus 1i. And so if you think of the Pythagorean theorem, is 1 squared plus 3 squared would be this distance squared, x squared. Then when you solve that, you get this distance, this third side of the triangle is radical 10. So even though we're talking about complex numbers, to do its distance, it's just you take the square root of each number, the coefficients squared, just like the Pythagorean theorem. So the absolute value of a complex number is a distance or magnitude. Okay, so just like the absolute value on a number line is a distance, it's just in 2 dimensions. You know, it's not just like on the number line. Okay, so that's going to be important in our practice. Okay, so the absolute value of a complex number, a plus bi, is defined as the distance between the origin and AB, where a and b are the coefficients. And so to get that, it's the square root of a squared plus b squared. And so that's really similar to the distance formula. It's just that the other point is 0, 0. So that's why we don't really worry about the distance formula. We just do this. Okay. So Now, if I just had a real number like 3 plus 0i, well, its absolute value would be the square root of 3 squared plus 0 squared, square root of 9, which is 3. So even like a real number like 3, you could still use the same idea to find its absolute value. Okay, just think of the imaginary part as 0. So, but it's the distance that number is from the origin. So there's other words that other books use. Normally I will use absolute value or distance, but often the word I will also use magnitude. Okay. Your book uses the word modulus some, but I never use that word. Almost never. I'll just say magnitude or absolute value, but it's the same thing. So it's the square root of a squared plus b squared. All right. So if it says plot a complex number and find its absolute value. So to plot it, so -2 plus 5i. So again, you go on the real axis first, and then the part with the I, you go up on the vertical axis is the imaginary axis. So there's -2 and then plus 5i. So it's like graphing the point -2, 5. And then to find this distance, then you say -2 squared is 4, 5 squared is 25, add them up, take the square root. So the square root of 29. And if it doesn't come out to be a perfect square, you can just leave it as a radical. No problem on that. So square root of 29 would be that distance from the origin to that complex number. Okay. All right, so you guys try that one, please. All right, so Andrew, what is the absolute value of 3 minus 4i? All right, Andrew, you need some help?
Yeah.
Okay, so you take 3 squared plus -4 squared, add them up, and take the square root. So that's 9 plus 16 is 25. Square root of 25 is 5. Really don't even need a calculator for that one. Okay, then to graph it, 3 minus 4i, you go over 3 on the real axis and then down 4 on the imaginary axis. So this point right here is 3 minus 4i. All right, any questions? All right. So now Z represents the absolute, the complex number. So if I say the absolute value of Z is less than or equal to 1, consists of only of those complex numbers with an absolute value less than or equal to 1. So which of these graphs would represent that? Where it has an absolute value less than or equal to 1. Would it be the blue or the green? The complex numbers with an absolute value less than or equal to 1.
The green?
It would be the green. Because you're talking about all the points that have a distance. So it doesn't matter if they're up, down, left, or right. Their distances are less than or equal to 1. So it would be inside this circle. Okay, good. All right. Now this one says graph the region in the complex plane defined by the following. So Z is a complex number, and we're saying the absolute value of Z is less than or equal to 1, and B is greater than 0. So the B is the part, the imaginary part. So the imaginary part, the B, the number in front of the I, is greater than 0. All right, so see if you can kind of figure out what that graph would look like. All right, so the difference between this and the example is just this first part. So if you start with the circle like we had, where it's filled in, that would be this part. But we only want the part where the B is greater than 0. So what we want here is just the top half. Okay, so just the top half of that circle. All right, any questions on that?
So on our practice, it says B is greater than or equal to 0, so would it be the same answer
Yes.
for the practice?
Oh, is it a little different? Oh, or equal to. Is that what you're saying?
Yeah.
Okay, yeah. So then if B is equal to 0, then it would be on this line right here. So you would fill that line in. So instead of it being dotted, it would be solid. So good catch. So let's change that. So then it would be filled in as well. Okay.
So for an equation like this, we're only looking at the variable b, whatever's in front of I.
Yeah. Well, this part said that the magnitude or absolute value is less or equal to 1. So that's how we got the circle. The inside where every distance is 1. So it's everything that's inside of that. But this part, the extra part says, well, the B, the imaginary part has to be above the x-axis. It has to be positive. Because these points down here would be like 2 minus 3b, or 2 minus 3i. And so this is saying that the b part, the imaginary part, is not negative. Does that help a little bit, maybe? Okay. Whoop. Okay, so next we're going to have what we call the trig form of a complex number, okay? Now, this part right here that's highlighted, this is what we call the trig form. So it's, matter of fact, we've talked about all this other stuff. So let's just focus on this. So Z equals R times cosine theta plus I sine theta. That's the trig form. Now, sometimes I will write these answers in what's called CIS form, which is kind of an abbreviation of this, where you'll have the R and then CIS and then theta. So it's really the same thing. It's just an abbreviated form. And then we have the polar form that we've already learned, where it's R theta, and sometimes you'll see it written like this. But when it asks for the trig form, then usually we'll want this, or I would accept that, that's the CIS. And you'll kind of get an idea for what that means. But we've talked about R and theta, but see, we have, with the complex numbers, you have an I in front of the sine part, because that the vertical part is the imaginary. All right, so -2 plus 3i, that's in complex form. So if we want to write that in trig form, then what we need is the R and we need theta. Okay, so it's similar to when we converted the Cartesian points to polar points. It's the same idea. You say, okay, I need to find the R. Well, how did I get that? Well, -2 squared plus 3 squared. Okay, let's see. And then theta, theta prime is the inverse tangent of b over a. So 3 over -2. And so I get 56.310. You might remember, though, that only gives you the reference angle. So you have to make sure that you're in the right quadrant. So you think, well, -2, so -2 plus 3i is in quadrant 2. 56, though, is in quadrant 1. So what we have to do is subtract that angle from 180 to get the angle in quadrant 2. So now this is the correct angle, and this is the correct R. And so then, to put it in the formula, the answer then is radical 13 times the cosine of the angle plus I times the sine of the angle. So that's the trig form. And so the CIS, I like, the CIS form, I like it because you don't have to repeat yourself. So you just put the R, and then that means cosine plus I times the sine. That's what CIS stands for. And then you just write the angle once. So you don't have to write the angle twice, and you're not having to spell out sine and cosine. But so this means that they're equivalent. They're both considered trig forms of the complex number. So you have to find the R and you have to find the theta, and then you plug it in. Okay. So any questions on finding the R or the theta? Since we've done that before, I kind of went through that fast, but if you'd like me to go slow down and go through that again, which part?
Just when you got the tangent of 3 over -2, so why did you do that? Like, how did you know to do that?
Okay, so the formula is the inverse tangent of b over a. Okay. So here, let me write those formulas down that I'm using, so that remember, r squared equals x squared plus y squared, and then whoops. And theta prime is equal to the inverse tangent of b over a. Okay, but this, just the theta prime gives you the reference angle. Okay, and so going back to our problem here, see the b over a, see, we had 3 over negative 2. And so when I put that in the calculator, inverse tangent of 3 over negative 2, I get 56 degrees. That's in quadrant 1. But this point, negative 2 plus 3i, negative 2 plus 3i is in quadrant 2. So I have to subtract that from 180 to get that angle in quadrant 2. Is that better?
Yeah, thanks.
Okay. All right. Other questions on that one? All right. Think you can do one? Let's have you do one. All right. So write the complex number 6 minus 6i in trig form. So you have to find the r and the theta first.
When you're finding the angle, do you keep the negative with it, or
Yeah.
do you?
Yeah. When you're putting it in your calculator. So in this one, you'll do the inverse tangent of negative 6 over 6, or the inverse tangent of negative 1. Actually, that one's on your unit circle. So what angle would have a tangent of negative 1?
45, right?
45 would be positive
Oh.
1. So it would either be, but 45 is your reference angle.
Mm-hmm.
So let's figure out, so what quadrant is 6 minus 6i in? 4. That's right. So 6 minus 6i. So then if you've got 45, it's just going to be negative 45 to get in quadrant 4. Does that make sense? Okay. All right, so Ellie, what is the magnitude of this? What's R?
Radical 72.
Radical 72. Okay. Now, the thing I don't like about radical 72 as an answer is if you, I don't mind you leaving it as a radical, but this has a perfect square factor because 72 is 36 times 2. So I would want you to either write it as 6 radical 2 or 8.485. But radical 72 I wouldn't like because it's not simplified. So either one of those. Okay, so that's R. All right, now we got the angle was negative 45, right? So now you could have had it in, that's the same thing as 315, or you could do it in radians. But actually, if you left it at negative 45, that would be okay. All right, so now, so putting that together in the trig form, let's see. So, so you could say 8.485 cosine of, and then negative 45 or 315 degrees plus I sine negative 45 or 315 degrees. And so you could have this out front or the 6 radical 2. Okay. And then if you did the angles in radians, that would be okay too. Okay. So we all good with that?
So that's like the whole answer?
That's the whole answer. So really the thing is you got to find R, you find the angle. So, and we've done that before. What's new today is putting it in this formula. The R cosine the angle plus I sine the angle. That's what's new. That's the new part. Okay? Now, if you did it in the CIS form, see, I like the CIS form because it's more compact. So 8.485 CIS, 315 degrees. So now, for what we're going to be doing later in this section, taking these complex numbers and adding or multiplying, divide them, raising them to powers, taking the roots, we need to have it in this form. So this form is going to be critical. So we're going to keep doing this, okay, is putting the numbers in that form. All right, so now the standard form of a complex number is a plus bi. So usually that's where we start, or it'll say, you know, put your final answer. So maybe if it's in trig form and we want it in standard form of a complex number, that means we want to put it back into that form. Okay. So let's go backwards. So now this one's in CIS. How do we go back to a plus bi? All right. Well, if we think of this as 15 times the cosine of the angle plus I sine the angle. Okay. The easiest way to do this is just put it in the calculator. Okay. Just put it in the calculator. Now, so I would do it, so 15 times the cosine of 37, that gives you the real part of the answer. So 11.980. And then the I part is you do 15 times the sine of 37, and then just slap the I at the end. So 15 times the sine of 37 would be 9.027, and then you're just going to have the I. But see, this is of the form A plus BI. So this is the complex form. Okay? So now this one is polar form, but it's the same thing. So think of this as, so do 2 cosine the angle plus 2 sine the angle times I. I guess I could, yeah. So now, so put that in your calculator and get an answer in standard form of a complex number. Or since this is an angle on the unit circle, you could use the unit circle and not even use your calculator. All right, so Cameron, when you've got it.
I got 1.732 plus 0.5i.
Okay, I've got the 1.732 plus, so here, see the sine of pi 6 is 1/2. And so when you in the 2, when you multiply 2 by 1/2, you just get 1. So 1i should be for the last part.
Oh, so you like distribute the 2 into
Yep.
both?
Yep.
Okay.
Yep. Okay. All right. Any other questions on that? Okay. All right. So let's go ahead and try this one. Did I leave this one on your sheet? Is this on your sheet?
Yeah.
Okay.
Yeah.
Yeah, I couldn't remember if I took it off or not. I was kind of debating. But let's go ahead and do that one. All right, so Junior, when you've got it.
-4 plus 6.928i.
-4 plus what?
6.928i.
928
Yeah.
I. Okay, did everybody go with that?
Yes.
Any questions? All right, good. All right, so now, let's see. All right, let's go to multiplying. All right, so when we multiply two numbers that are in complex form, then what you do is you just multiply the r's, the numbers in front, and then you add the angles. Okay, so if you've got your two complex numbers in trig form, then you just multiply the numbers in front and add the angles. Now, that actually makes it so much easier once they're in trig form. Okay, so let me give you an example here. All right, so let's say these are my two numbers, my two complex numbers, and they're already in trig form. So then to multiply them, v times w, all I do is do 2 times 5 is 10, and then I add the angles. 45 plus 15 is 60. And that's it. That's the answer. So I'm able to do this mostly in my head once I have them in trig form. Okay? So you multiply the numbers in front and add the angles. All right, let's see if you can do practice 3A. All right, so Cameron, when you got it.
12 cosine 90 plus I sine 90.
Excellent. Okay, everybody cool with that? All right, now, sometimes when you have one like this, especially when the angle ends up being one on the unit circle, like 90, then they'll actually simplify it, and because you can still get an exact answer. So what is the cosine of 90?
0.
And what's the sine of 90?
or 1, I mean.
1.
Right.
Okay? So then, so you could write it as 12 CIS 90, but then if you simplify it, see, the cosine of 90 is 0, and the sine of 90 is 1. So the 12 times the 0, this part just goes away, and so this part you just get 12 times 1 times I. So you end up with 12i as your final answer. Now, I'm not saying that you're going to have to do that every time or whatever, but if you're ever doing these and you check the back of the book and you're like, wait, why is part of the answer gone? Well, it's because they've simplified it. Okay? And so, you only see that if the angle that you end up with is on the unit circle. Do they ever even try that? But I like your answer that you gave me from the beginning. Okay. All right. So now dividing. So when you're dividing, so you've got the two numbers, two complex numbers, and they're in trig form. Then basically to divide them, you divide the r's in front. So it's r1 divided by r2. And then it's cosine of, you subtract the angles, okay? So let's say theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So it's similar to multiplying. When you divide the numbers in front and then subtract the angles. So once again, these are ones that you can kind of do in your head now. So if we're trying to divide these two complex numbers, you just divide 6 divided by 2 is 3, and then subtract the angles. 117 minus 72, and so you get 45. So it would be 3 CIS 45. All right? So try that next practice problem. Oh, okay. Let me go to it. So I like these because they look all complicated, but you can do them in your head. Impress your friends at your next party. Show them how to do this, right? All right, so Dominic, what do you get for this one?
4 cosine of 30 plus I sine of 30.
And the 4 does apply to both, so you need to make sure you put the parentheses there, or write it as 4 CIS 30. Okay? Great job. Now, because 30 is on the unit circle, we could plug in the angles and simplify, but I think we're good with that. Okay? All right, let's see. All right, I think that's a good place to stop. We'll just kind of pick it up from there. We'll have Mr. Fritz. We'll either finish there, or if we'll just figure it out. Anyway, I hope you guys have a great spring break. Be safe. Don't do anything crazy. Hope you travel well. And good luck on your midterms. Don't hesitate to reach out to me. Shoot me an email if you have some kind of concern or whatever.
Have a good spring break.